So now moving on to the next presentation. This is from TrinaSolar. David Germania is going to talk about why the time of TOPCon has arrived now. So TrinaSolar's N-type modules. And David is the Senior Product Marketing Manager at TrinaSolar. David, the floor is yours.
Yeah, a second, let me share my screen. Yeah. Okay, so can you see my screen?
Yes.
Okay, so thanks everyone for the chance to be here today as Trina to try to explain our view on N-type, right? So for today's sessions, we have split our presentation in four main topics. First of all, we will talk about our, let's say, history and backgrounds on N-type. Secondly, we will talk about which is our product roadmap and portfolio on N-type. Also, we will explain what we consider are the key differential features in our product portfolio on N-type product offering. And finally, we will conclude with some LCOE analysis done by independent third party, making a comparison between Trina technology and other technologies in the market. Right. So starting with the history and background, just to say that, of course, for N-type TOPCon technology is not new at all for Trina, right? In fact, we started in 2015 with the patents and with labs in order to evolve the TOPCon cells there. And there later on in 2019, we announced to the market the efficiency of our N-type TOPCon cell in laboratory, and then we became the first module supplier to deploy this into mass production. And from there, just breaking the efficiency record year by year up to now. Also, just to say in terms of track record and project reference that we already delivered some time ago our N-type TOPCon modules for really big projects, especially as you can see in the slides, for example, for our top runner project of 500 megawatts in China, and also for other relevant projects of 135 megawatts also in Shanghai province of China. Well, having said this, which are our main pillars and levers for our N-type product offering? Well, there are mainly four. First one is that we use our large wafers, G12 and G12R. We are, TrinaSolar is purely convinced about the use of large wafers and also the benefits that this FAT is giving to the modules and also to the complete PV plant. So nowadays, most of our manufacturing capacity is already migrated to these modules based on G12 and G12R wafer sizes. Also, we use multi-bus bar technology in order to increase the overall efficiency of our modules, reaching a trade-off between optical and electrical efficiency. We can go up to 18 cables, even in the cases of really big power modules. Also related with efficiency, we use a high density of interconnection in all of our modules in order to reduce minimum distance between adjacent cells in a module, trying to also increase the overall efficiency of them. And finally, last but not least, let's say all of our modules are using NDC technology, non-destructive cutting technology, in order to provide higher reliability and also bigger mechanical strength and mechanical performance, avoiding any kind of potential microcuts appearance. So regardless if the modules is being addressed for residential applications, triple cut, or for utility scale half cut, then all of them are using NDC. Well, let's try to look now a little bit more on detail our product roadmap and portfolio for N-type. Well, first of all, as you can see in the slide, it's a wide portfolio trying to cover all potential segments and applications in the market, from the more distributed energy applications up to the utility scale. So starting with the more distributed applications, here in the left, we have our Vertex S Plus product, mainly thought for residential rooftops and with power bins up to 440. Then we have our 19R series with our NEG 19R C20 module, mainly thought for large CNI and especially for utility scale applications with power being up to 590 watts. And finally, we have our 21 series, means our Energy 21 C20 module with power beams up to 685 watts, and mainly thought for utility applications. And the important message here is that if you use Trina solar modules, you can get in the range of 30 up to 90 watts more in power beam per module than the standard of the market. Moving forward to more utility scale applications, here you can see in this slide, let's say our advice in terms of product positioning, right? We have two main series, our 21 series and our 19 series. So if you want to get the best LCOE or the lowest LCOE, just pick the 21 series, right? This is a model which is fully compatible with our same series 21 PERC P-type technology using G12 wafers. And regarding to the fact of getting the best LCOE, this is going to happen. It's going to be right for all the cases, 100% of the cases. Probably not, right? It depends on the terrain, depends on other project boundaries. But for many combinations, and according to our internal analysis, probably this one can be the best, getting the best LCOE. However, also we have a broad portfolio of NEG19, our 19R series with a NEG19RC20. And with this model, we reach a wonderful, let's say, trade-off between good value of LCOE, getting a really low value of LCOE, probably not so low, not so good as 21 series, but also on the other way, giving obtaining a really great value in terms of flexibility. What does this flexibility concept means? It means that this module fits in every terrain, in every PV like that. It's also really nice, compatible with all main trackers and brands models in the market, and in other type of boundary conditions for the project. So this NEG19RC20 module is also fully compatible in terms of dimensions and electrically with our similar series in P-type PERC technology, and is using G12R wafer. So once that we see a little bit more about the product portfolio and of what we have in terms of N-type product offering, let's try to explain a little bit more in detail which are the main differential features that we see in our N-type product offering, not only for the module itself, but also how they contribute to reduce LCOE and to enhance the performance of the PV plant. So in this sense, we will explain why we are using two different wafers or two different modules based on different two wafer sizes, with the chance to be to fit even better in all type of terrains, layouts, and in boundary conditions. Also, we will explain how from the very beginning designing phases, all of our modules are designed to reduce the logistic cost. Also, one important point here, we will explain how from the module point of view, we can help to contribute to reduce the cost of other key components in a PV plant, such as the trackers. And finally, we will explain which are the key features in our N-type product portfolio in order to increase the yield of global PV plants. So starting with the different wafers, and you can see here in this slide a summary on the left side. On one side in the market, we have N10 wafers, which are square boxes of 182 by 182 millimeters. Then on the other side, we have G12 wafers, which are also square boxes of 210 by 210. And somehow in the middle, we have G12R wafers, which are rectangular. The R means rectangular wafers of 210 by 182. And the good point here is that using or manufacturing and producing modules using or based on these G12R wafers, these modules inheriting all the good benefits of both wafer sizes, right? G12 and M10. So on one side, these modules are being able to be manufactured with a really extremely low open circuit voltage. And that means that we are able to allocate more modules per string and therefore higher power per string. On the other side, on the other way around, these modules can share the same dimensions, especially the same width as 182 millimeter modules based on N10 wafer. And as we will see later on, this is a tremendous benefit in order to get a better compatibility and a better performance with most of the trackers in the market. But let's try to see this one with one example. Here you can see the summary conclusions for an analysis done in a typical PV plant installation based on 1500-volt technology, in which we compare the performance of our N-type 21 series with our N-type, N19R N-type series, and finally with a reference module on N-type of 182 millimeter wafer size. Starting with our N-type 21 series of a power bin of 680, you realize that is a module with based on G12 wafer with extremely low open circuit voltage, which allows us to configure, in this case, up to 29 modules per string. So that means in terms of a string that we are talking about a string power of roughly 20 kilowatts and a string length of 38 meters. However, if we repeat the same analysis with our NAG19RC20 module and a power bin of 590, you realize that this is a module based on G12 wafer, also with extremely low open circuit voltage, just pretty close to our 21 series module, which allows us to configure up to 29 modules per string. So in terms of a string power, that means 17.1 kilowatts and a string length of 33 meters. And finally, we go for a reference module of 182 millimeter wafer size and N-type technology and power unit of 580. You will realize that, for example, in this case, the open circuit voltage of this module is significantly higher than in Trina modules, which allows only to configure up to 26 modules per string. So in terms of a string power, that means 15 kilowatts, which is significantly lower than in Trina cases, and a string length of 30 meters. So the good point here is that with both combinations above, I mean the NAG19RC20 from Trina and the reference module 182 millimeter, you can use or allocate the same number of strings per tracker with the main trackers and models in the market, but in the case of Trina with higher power bin and with the savings that we will see later on. In terms of logistics, as you know, from TrinaSolar, we have invested a lot of time and resources to create innovative packaging solutions, such as the vertical portrait packaging and the landscape, vertical landscape packaging, in order to increase the number of modules per container and therefore the power per container. So looking forward to our N-type main modules for utility, you can see here that for our 21 series, we can allocate up to 594 modules, which means 404 kilowatts per container. And in the case of a 19R series or module, we can allocate 720 modules per container, which means 425 kilowatts. So, and this is, I should say, one step ahead if you compare with the standard of the market. So in a context in which nowadays the shipments and the logistics are really important, this is making also the difference. Well, let's see now one important point, right? As I mentioned before, how from the module point of view, we are able to contribute to reduce really the cost of other key components in a PV plant. And here in this slide, you can see the summary conclusions for several case studies that we did for projects in Spain, typical 50 megawatt project reference in Spain, in two different configurations, one P tracker in dual row and one P tracker in single row. And for each one of the configurations, we compare the performance of two different modules, our NAG19RC20 N-type rectangular wafer, and the classical N-type approach reference module with 182 millimeters cell size. And as you can see in the 1P tracker B row, with both of them, we can configure or can allocate to the same number of strings, so it means 2 strings per row, 4 strings per tracker. But the good point with Trina is that using this NAG19RC20 module, you can increase the power per tracker in a 15% and reduce the number of trackers and the pulse per megawatt in a 13%. You know that the cost of the piles is a representative cost of the total tracker cost, right? So, and the rationale for the 1P tracker in single row configuration is roughly the same, right? Using our 19R series, you can increase the power per tracker in a 15% and reduce the number of trackers and paths per megawatt in a 13%. So with our tracker models and brands, which are fully reliable and with all the wind tunnel test configuration paths, you can realize that from module point of view, we can contribute to also help contribute to reduce the cost of other key components such as in this case 1P tracker. And what about the yield? Well, all of our N-type models are bringing differential features or key features in order to increase the yield of the PV plant. For example, all these modules are bringing with higher efficiencies in the range of 22.1, 22.2, right? And also with higher power bins up to 685, which is a differential feature between classical approach in PET. But even more important, all these N-type modules are bringing enhanced degradation profile. For example, 1% first year, so it means no LID phenomena, and 0.4 from year 2 down to year 30. And whenever that you introduce this into your financial modeling, you will realize the differences in terms of revenue stream. Also, these modules are coming with a better thermal behavior and coefficients, so it means less derating of power per temperature, which is also relevant for these areas of sites in which the climate conditions are really demanding. And finally, also these modules are bringing best or higher values of bifaciality in the range of 80–85% versus the classical approach in PERC of 70%. So having said this, I'm trying to move from, let's say, a qualitative perspective into more figures or into a quantitative perspective. We bring for you today was some of the conclusions of the analysis that we were doing with during the last months and years with several independent third parties all over the world, right? And in this sense, we work with Black & Veatch in US, we work with Enertis in Brazil, with DNV in Spain, with Fraunhofer in Spain, and in Germany, and with Dual in Middle East and Australia. And with all of them, what we did, what they did, all of them, they make a LCOE comparative assessment between different technologies, Trina 1 and other ones based on M10 wafers and even M6 wafers, right? And of course, the figures are not only always the same in all the projects all over the world, right? Because the boundaries of the projects are different. But what is always the same are the conclusions and the trends. If you use Trina modules, you can save, according to this analysis, in the range of 1 cent of a dollar per watt peak in capex wise, and you can reduce LCOE in the range of 2 up to 4%. And this is not about what we are saying from Trina. This is about what others, which are absolutely independent third parties, are saying regarding this debate. Right. For today, as we don't have too much time, we only bring one example of this LCOE assessment for a small project in Germany of 10 megawatts, in which we compare our N-type modules, 21 and 19R series, versus an N-type reference module on N10 technology. And as you can see on the left side, we show a simple breakdown of the capex, in which you can see the benefits of using Trina and large wafer modules, right? Less number of modules, less number of containers, less number of strings, less quantity of DC cables, probably less installation cost of the module to the tracker, less civil works, etc. But apart from the key values of the discussions about that the figures are being done well or not, for us, the interesting message here is that the potential savings in the capex are not related to the technology of the cell. It means if you are using P-type or N-type. The potential savings in the capex are strictly related to the wafer set that you are using in your modules. So as far as you increase the wafer dimensions, you will realize.
Sorry, David, you have to finish in 1 minute.
Yeah, it's 1 minute.
Sorry.
You will realize the savings in the balance of systems and therefore in the capex. So all these benefits in capex are also transmitted to the LCOE, as you can see in the slide. And just to conclude this presentation, we wanted to give you a snapshot about our capacities for N-type. As we already explained, our NEG19 RC20 module is ready to order and for deliveries in Q1 next year. For Q1 next year, we are pointed out to a capacity of 10 gigawatts and a total capacity for next year, 2023, of 30 gigawatts. So that's all on our end. Thank you very much for your time and for your attendance. And now we remain open for all potential queries.
Okay, thank you very much for this nice presentation. So I have really one quick question. So you mentioned G12 and G12R. So which is going to be your mainstream? So are you going to put both, or one is going to be your mainstream? Can you just quickly answer?
Yeah, we are going to use both because as I trying to explain during the presentation, we see the benefits of using both, right? Of course, using big wafer or the G12 probably is getting us to manufacture modules which are probably get the best LCOE for the PV plants under certain boundaries. But with the G12R, we can see that we can reach this wonderful trade-off between getting a really good value of LCOE, but also having this flexibility of our modules, dimensions, and so on, to try to fit even better in all type of conditions, terrains, layouts, and boundaries of the project. So there's not going to be like a different mainstream. Obviously, our G12 is, let's say, our mainstream nowadays, but for sure that we are going to use both of them.
Okay, thanks. And